Okay, let's look at the definition of a function. A function, which we usually denote by a lowercase letter, typically f, from a set A to a set B is a relation, and it's a relation with some additional properties. It's a relation that assigns to each element x in the set A exactly one element y in the set B. So here I've drawn just a general map of what a function might look like. We have a set A, and we have elements in the set A. Let's say one of them is x. The function f acts like an arrow, pointing from the element in A to its pair in the set B. Now, that said, all the elements in A get assigned, and they're assigned to exactly one element in Y. So you would never see, say, this x going to two elements in the set B. That's the main restriction on a function. We call the set A the domain. And this is typically known as the set of inputs to the function. We call the set B the range. That would be the set of outputs to the function. Let's look at a function. So here's an example. It's a relation, clearly. It's a set of ordered pairs. This also has the property of being a function, because we can see that every pair, for every input, there is no repeated output. So -2 goes to 5, 5 goes to 1, 0 goes to 1, and 4 goes to -2. So there are no repeated inputs going to different outputs. Let's figure out what the domain and range is of this function. So the domain this would be the list of all the first coordinates in these pairs. So the domain will be -2, 5, 0, and 4. The range, that is the set of outputs, would be the second coordinate. So we have 5, 1, 1, we've already written 1, so we don't need to write it again, and -2. Okay, so let's look at some more characteristics of functions and some more examples.